Okay, so in today's video we're going to have a look at quadratic simultaneous equations. So we're going to be building this up throughout the video. So we're going to start off with some of the easier ones, although all of these are quite hard topics. Okay, it's actually one of my favourite topics, so quite excited to do this one. But here we go, we're going to have a look at quadratic simultaneous equations. Now, just thinking about what we're actually finding here. Now, this first equation, we're going to be having a look at all these sorts of equations here, where one is a circle and one is a straight line. And if we think about that, what that would actually look like without drawing a full graph, if we had a circle and a straight line went through it, there would be two solutions there. There'd be one where it crossed over here and another where it crossed over here. That is, of course, unless the straight line is a tangent, which could be quite hard for me to draw, but if it was a tangent, it might just touch the circle at one point there. So it could actually only have one solution, but the majority of the time these are going to have two solutions. Now let's get rid of that. Now, in order to solve a simultaneous equation, we have to think about eliminating one of the variables. So eliminating either the x or the y, just like when we have a look at normal simultaneous equations, but there's a different process when it comes to these harder ones here. So grab a piece of paper, grab a pen, make some notes. We're going to have a look at some of these questions. Now for this first one, it says x squared plus y squared equals 13. And the second one says, well, x equals y take away 5 or y minus 5. So essentially, if we can substitute, which we can substitute this y minus 5 in place of the x, because it says x equals y minus 5, then we can actually eliminate one of the variables there. Now the way to do that is if I just stick a bracket around this y minus 5, I'm just going to put that in place of the x up here, and let's see what we get. So getting rid of the x and putting the y minus 5 would leave us with this. We'll have y minus 5, and that is x squared, so that's going to be squared, plus y squared, and that equals 13. Now we've got an equation that has no x's in. Now, as long as we've only got one variable in there, we can definitely solve it. Okay, but it's gonna form a quadratic, okay, with y's in, but we can actually definitely solve that. So if I just go about expanding this bracket to start with, obviously I'm going to take my time with the first one here, but I might skip a few steps as we move on. But that y minus 5 squared is a double bracket. So if we work that out first, we've got y minus 5, y minus 5. And if we expand that, let's see what we get. So y times y is y squared, then we get minus 5y, minus 5y again, plus 25. I'm obviously assuming that you are quite comfortable with some of the topics in this video here, so expanding a double bracket, and later on we're going to have factorising quadratics as well, and substitution, and a few other bits of maths. So I'm going to assume that you're quite comfortable with those if you are watching this video. If not, obviously check out the algebra series in my playlists. Okay, everything's there. Obviously don't forget those playlists are there because there's quite a lot going on in those now. But if we have a look, if we simplify this, we get y squared minus 5y makes negative 10y, and then plus 25. So if I rewrite this equation here, let's bring it over here, we'll rewrite this, but rather than the y minus 5 squared, I'm going to obviously write that expanded version. So we get y squared minus 10y plus 25, and then we've got the plus, I've not actually written y squared there, let's fix that. I should say y squared there, plus that y squared, and that equals 13. Right, there we go. Right, so we can tidy this up because we've got those two y squareds there. So we can add those together and simplify that. So we'll have 2y squared. So 2y squared minus 10y plus 25 equals the 13. Now when it comes to solving a quadratic, we need to make this equal 0. So we need to subtract 13 from both sides. So if we get rid of that 13 from both sides, let's see what we get. We get 2y squared minus 10y. Take away the 13 from the 25 leaves us with 12, so positive 12, and that equals 0. Right, now we can solve this. Now we can do this in two ways. I can solve it from there, or I can have a look at all these numbers. Now all these numbers, or all these coefficients of y squared, the coefficient of y and the number at the end, they're all even. So if they're all even, we can divide both sides of this equation by 2. And if I divide everything by 2, both sides, obviously 0 divided by 2 is still 0 on the right hand side of the equal sign. But if we divide all of these by 2, we get y squared minus 5y plus 6 equals 0. Again, I've just divided everything by 2 there. Now, this is quite nice and easy for us to factorise. So we can factorise this as it is now. So 6, the factors are 6, we've got 1 and 6, or 2 and 3. So going into our double bracket there, we've got y, and we just need to get the right pairing here. That's going to equal negative 5 in the middle. And that's going to be negative 2 and negative 3. Now just be careful obviously, because you can make negative 5 out of positive 1 and negative 6, but we have got a plus 6 at the end there, so it's going to have to be negative 2 and negative 3, and that makes minus 5 in the middle and positive 6 at the end. Right, so we've got our two solutions for y. I'm going to bring those up to the top. In fact, I'm going to get rid of all this working out on the left. Let's get rid of all of this. Right, so we have, for y, our y minus 2 in the bracket gives us y equals 2, positive 2. And our y minus 3 in the bracket gives us y equals 3. So we've got two of our y coordinates there, thinking about obviously what I mentioned at the start, that crossover point of the circle and the straight line. So we've got y equals 2 and y equals 3. Now we just need to find what x equals for both of them. So we've got this equation here, this second equation. I'm going to get rid of those brackets. We've got x equals y take away 5. So if x equals y take away 5, then I can find x for both of these coordinates. All I have to do is take away 5 from both of them. So when y is 2, we get x equals 2 take 5, so x equals negative 3. And for the one on the right there, we've got x equals 3 take away 5 when y is 3, so that gives us x equals negative 2. Right, so we've got our solutions there. So we've got y equals 2 and x equals negative 3, and the other one we've got y equals 3 and x equals negative 2. Obviously thinking about how you could write those as coordinates, so the coordinate for this one on the left here would be minus 3, 2, and the coordinate for this one on the right would be minus 2, 3. And there we go, there's our solutions for this simultaneous equation. Obviously we can pair up the values there. We could just say when x is negative 3, y is 2, and when x is negative 2, y equals 3. So it just depends on how the question's asking you to write your answer there, but we could also write it as coordinates, thinking about what that looks graphically. Right, let's have a look at one more before we have a go. Okay, so solve these simultaneous equations. Now, it's a very similar question here, but we've got something slightly different than the second equation, because that second equation there, this x minus y equals 2, doesn't say y or x equals. So we're going to have to rearrange this just to make sure it says y or x equals. There's two ways we can do that. We can make it say x equals, or we can make it say y equals, but we're going to opt for one of the ways. Now, if I want to make it y equals, that's going to be the harder version here. I'll show you why. But if we want to make it x equals, we can just add y to both sides. So if I wanted to say y equals, and I'm going to get rid of these in a sec. Let's have a look. So if we want it as x equals, we'll add y to both sides, and we'll get 2 plus y, or y plus 2 if I write it the other way around. If I want to make it say y equals, which I can do, it's absolutely fine to do, I will have to move the pieces in 2 steps. So I could add, let's have a look, how could we actually do that? We could add y to the other side like we've done, and then subtract 2. So looking at the equation above, x equals y plus 2, we'll take away 2 from both sides and we get x minus 2 equals y. Now, it doesn't matter which one we actually use here, simply because on the last question I actually looked at solving for y. Let's have a look at solving for x. So I'll use this second one here. So x minus 2 equals y. It is important that you can rearrange it in both ways, but that's just how we would have to arrange it if we wanted it to say x or y equals. So let's go for this second one. X minus 2 equals y. So if I sub that in place of y this time, again taking the same approach as before, y equals x minus 2. So x minus 2 I'm going to put in place of the y there where it says y squared just here. So let's sub that in. So if I sub it in, I get x squared plus, now instead of y, I've got this x minus 2, so x minus 2 squared, and that equals 34. Okay, so let's actually expand this. We have the x squared at the start, and then we've got a double bracket. So again, I'm going to skip a step here. Rather than doing the double bracket, I'm just going to expand it, but you can feel free to write it out. So x times x will give us another x squared. We've got minus 2x twice, so minus 4x. And then negative 2 times negative 2 will give us positive 4 at the end, and that equals 34. Right, we can tidy this up. We can join up those x squareds. So we have 2x squared minus 4x plus 4 equals 34. And then again, we just need to make this equal 0. So we can subtract the 34 from both sides. So let's do that. Let's subtract 34. So we still have 2x squared minus 4x. Subtracting 34 from 4 gives us negative 30. So there we go, negative 30 minus 30. And now it equals 0, and we can factorise it again. So same process for factorising. Let's think of if we can simplify it first, which we can. We've got a 2, a 4 and a 30 there. So we can divide everything by 2. And we get x squared minus 2x minus 15 equals 0. Right, so we can factorise now. We could have factorised before, but it just makes it a bit easier here for us to factorise. So the factors of 15 we can have Let's have a look and let's write this in a different colour. 3 and 5, or 1 and 15. And let's think, we want to make negative 2. So positive 3, take away 5, that'll factorise for us. So we have x plus 3 and x minus 5. There we go, and that equals 0. And again, we get our two solutions there. So in the x plus 3 bracket, we get x equals negative 3. And in the other one, we get x equals positive 5. Right, there we go. Now our equation that we created above, this one here, y equals x minus 2, allows us now to just sub that in, these x values, in order to get our y values. So if y equals x minus 2, then when x is negative 3, y equals negative 2, take away that 3. Oh, I've not written that the right way around, let's move that. X minus 2, so negative 3, take away 2, we've got the same answer there, but there we go, let's write it the right way around. Negative 3 take away 2, which is negative 5. So there we go, y equals negative 5. And for the one on the right there, we've got y equals, let's get it the right way around this time, 5 take away 2, x minus 2. And 5 take away 2 is 3, so y equals 3. And there we go, we have our two solutions. We've got when x is minus 3, y equals negative 5, which again we can write as a coordinate, minus 3 minus 5 if we need to. And the other one there, we've got when x is 5, y equals 3, which again we can write as a coordinate, x is 5 and y is 3. Right, there we go. So thinking about what we've done there, we are rearranging our second equation if we need to, just to make sure it says x or y equals, substituting it in place of the x or y in the circle equation, expanding it all out, tidying it up, making it equal 0, simplifying if possible if we need to, factorising, solving, and then resubstituting it back in to find our y or our x values depending on what we've solved for. So there's a lot of steps there, a lot going on. Okay, so hopefully you've made some good notes on that. It is quite a nice process question whereby, you know, all of these questions are going to follow a very similar process. So let's have a look at some for you to have a go at. Okay, so here's two questions. So have a go, pause the video there, and we'll go over the answers in a sec. Okay, so the first one. Now this first one, the second equation doesn't need rearranging, so we can sub that straight into the position in y, and we get x squared plus x minus 3 squared equals 17. And if you expand all that out, you get x squared plus x squared minus 6x plus 9 equals 17. Tidy it up and subtract 17, I'm going to do it in one step. So 2x squared minus 6x, take away that 17 from the 9, so 9 take away 17 is negative 8, so minus 8 equals 0. Simplify that, so let's divide everything by 2, we'll get x squared minus 3x minus 4 equals 0. Factorise it, it's 1 and 4, positive 1 take away 4 will make negative 3 in the middle, so x plus 1 and x minus 4 equals 0. Then let's get our solutions. So x equals negative 1 and x equals 4. And then we need to sub those into that top equation. So y equals x take away 3. So if it's y here for the negative 1, we've got negative 1 take away 3, which is negative 4. And for our other one here, we've got 4 take away 3, which is positive 1. And there are our solutions. Okay, right, let's move on to the next one. So we need to rearrange this. Now again, you might have done this in two different ways. I'm going to add x to both sides. So we'll get y equals x plus 3 or 3 plus x. I'm going to leave it as x plus 3 though. There we go. And now I'm going to sub that in. Again, you'll get the same answer if you've done it the other way, but that was the quicker way there. So let's sub that in. We're going to solve it this way. So replacing the y again, we get x squared plus x plus 3 squared equals 29. There we go. Right, expanding that all out, we get x squared plus 2 lots of 3x, so 6x plus 9 equals 29. Let's add those x's together, so 2x squared plus 6x, take away 29 from 9 gives us minus 20, and that equals 0. Again, let's simplify it, so divide everything by 2, we'll get x squared plus 3x minus 10 equals 0. Now we can factorise, so two numbers at times to make 10, we've got 2 and 5, and we can make 3 out of that, positive 5 take away 2, So x plus 5 and x minus 2. There we go. And that makes positive 3 in the middle and negative 10 at the end. So that's fine, that works. X equals 0. So we've got x equals negative 5 for this first one, and x equals 2 for this second bracket there. And then subbing it back into our equation that we created up here, y equals x plus 3. So we just need to add 3 to both of them. So y equals negative 2 when we add 3 to negative 5, and y equals 5 when we add 3 to 2. And there we go. There's our two questions. Let's have a look at something slightly more difficult. Right, okay, so solve these simultaneous equations. Now, a little bit trickier here because we just have a 3x rather than an x there. Obviously, I have two ways of rearranging this. We can make it x equals or we can make it y equals. Now, you should hopefully see which one I'm going to use and why. But if we make it y equals, let's have a look. We'd get y equals, I'd have to add y to the other side. So I would get 3x plus y equals 2. And then subtract 3x from both sides, we'll get y equals 2 minus 3x. There's one option. Now that is the option I'm going to use, but it might be on a quite a tough question that you have to actually rearrange it in a slightly different way if there was a coefficient of y there. And if I wanted to make it x equals, so if I wanted to make it x equals, I can do it in one step, but it doesn't look very nice. I have x equals 2 minus y all over 3 because I've got to divide by 3. So I've got two options there. Obviously that second one isn't going to be very nice, substituting a fraction in, but it can be done, it's absolutely fine to do. Okay, and I will actually have a look at some where you have to work like this on another video, but for the moment, let's just stick with those other ones there. So we've got y equals 2 minus 3x, okay, but just so you know, you can actually do it like that as well, but let's get rid of that. So we've got y equals 2 minus 3x. So that's what I'm going to substitute in. Again, remembering obviously we can stick a bracket around that, and we're going to put it in place of y. So if I stick that into the equation there, we have x squared plus 2 minus 3x, that's all squared, and that equals 20. So again, we just need to expand this and tidy it all up. So we get x squared. I probably would take a bit more time expanding this bracket here, so let's do that to the side. We've got 2 minus 3x and another 2 minus 3x. Okay, so 2 times 2 is 4. 2 times negative 3x is negative 6x. Negative 3x times 2 gives us another negative 6x, and then negative 3x times a negative 3x gives us positive 9x squared. So there's all our pieces. If we tidy that up, we get 4 minus 12x plus 9x squared, and we can put that in place now. Now what I'm going to do is I'm going to write that 9x squared first, just to keep it next to my x squared, so I don't forget to simplify them. So I've got x squared plus 9x squared minus the 12x, just keeping it in my normal quadratic order, and that's a positive 4, so plus 4, and that equals 20. So I've decided just to write that in a different way. I just prefer seeing it like that, so it's absolutely fine as long as we keep the symbols correct in front of those numbers. So tidying up these the 9x squared and the normal x squared, we've got 10x squared minus 12x, and then I'm also going to subtract 20 from both sides here. So plus 4, take away the 20, gives us negative 16. Again, I've done that in 2 steps there from that first question that we looked at. Again though, this is quite nice, they're all even, it simplifies, but it's not going to get us down to a single x squared at the start there. But if we divide by 2, we get 5x squared minus 6x minus 8 equals 0. That's fine, we can factorise this, but we've just got to remember here, if we've got a 5x squared, one of our brackets is going to be a 5x. So we've got a 5x and a 1x. There you go. Obviously I've got a video on factorising harder quadratics, so you can always have a look at that if you're not sure on these ones. But we've got 1 and 8 and 2 and 4, and we're trying to make 6 in the middle, and one of these numbers is going to get multiplied by 5. So we could have 5 and 8 for the 1 and 8. You can't make negative 6 out of 5 and 8. Or we could times the 8 by 5, and that would make 40 and 1. We're definitely not going to make negative 6 with that. So let's have a look at the other one. 2 and 4. Timesing 2 by 5 would give us 10. So 10 and 4 we can definitely make 6 out of. So we know we want the 2 to double to make 10. We want the 4 to stay as it is. And we want to make negative 6. So I want positive 4. Take away the 10. And there we go. There's our factorised quadratic there. So we've got 2 solutions. Now this one's nice and easy. X equals 2. And you've just got to remember how to work with this one here. So with 5x plus 4, you get 5x equals negative 4. Or x equals negative 4 over 5. Okay, you always just flip the sign and divide by that coefficient of x there. Okay, but let's have a look. There are 2 values then. So we've not got the nicest substitution now. Our x equals 2, 1's okay. Don't forget we've got this equation up here that says y equals 2 take away 3x. So for the first one, for x equals 2, and this one's our easy one, we get y equals 2 take away 3 lots of 2, or 6. So 2 take away 6 is negative 4, so y equals negative 4. And that's our nice solution, that's the one there. And then we'll have a look at finding our other one. And this one is a little bit harder. So our second solution, because we've got to substitute negative 4/5 in. So we've got when x equals negative 4/5. Obviously it's a lot nicer if you have a calculator, but if you had a calculator here, we could have used the quadratic formula, okay, which we're going to be having a look at next. But without a calculator, we're just going to have to look at how we sub that in. So y is going to equal 2 take away 3 lots of negative 4/5. Okay, right, so what have we got? 2 take away 3 lots of negative 4/5. You multiply the numerator by 3. Remember 3 is 3 over 1, so times in the top gives you 12, times in the bottom gives you 5. So 2 take away negative 12/5. Obviously we've got taking away a negative there, so that can just turn into a plus. So let's get rid of that, and let's just write that as a plus. Turn that back into a fraction, there we go. So we've got 2 plus 12/5. That's not too bad for us to do. I'd rather write 12/5 as a mixed number though. So we've got 2 add 5 goes into 12 twice with a remainder of 2. So 2 add 2 and 2/5. And if we add that together, we get 4 and 2/5. Which you could also write as a decimal, but I'm just going to leave it as a fraction there, 4 and 2/5. All right, there we go. And there's our y value. So putting it all together, obviously you can write your answers out here. We've got when x is 2, y equals negative 4, which again you can write as a coordinate if you want, but there you go, there's our first solution. When x is 2, y equals negative 4. And our other one there was when x equals negative 4/5, y equals 4 and 2/5. There we go, 4 and 2/5. It's obviously a lot trickier question there because that number that we had to substitute in second wasn't very nice. But obviously just thinking about how you rearrange it, it's the same process, just with a few extra little steps there and a few extra little bit of maths that you've got to think about. Right, here's one for you to have a go at. Okay, so have a go at this question. Pause the video there, we'll go over the answers in a sec. Right, okay, so rearranging this first one, or this second one, sorry, I'm going to take away 3 from both sides. So if we do that, let's rearrange this. We get y equals 2x minus 3. And there we go, we can sub that into our first equation now. So if we sub that in, we're substituting it in place of the y, we will get x squared plus this 2x minus 3. That's squared because it's y squared again, and that equals 41. Right, there we go. Now if I expand that all out and simplify it down, let's see what we get. So we get x squared plus, I'm not going to do a double bracket here, though you're fine to do that. We'll get 4x squared minus 6x twice, so minus 12x, and then plus 9, and that equals 41. Right, let's tidy that up and make it equal 0. So we get 5x squared minus 12x, and then 9 take away 41, and obviously just take your time working that out, gives you negative 32. So I've simplified that and taken away this 41 in one step. Now we need to factorise it. So again, it's a 5x squared. So we're going to get a 5x and an x. And there we go. And that equals 0. We just need to figure out what numbers are going to actually factorise for this here. So let's have a look. Factors are 32. We can have 1 and 32. We can have 2 and 16. We could have 4 and 8. Are there any others? Any other numbers? Let's have a think. No, not 3, not 5. 6 go in. No, not 6. Okay, so there are factor pairs there. So we're trying to make negative 12 in the middle, and again, 1's going to get multiplied by 5. Now, it's not the 1 and the 32, because 5 and 32 is no good, and we certainly don't want 160 and 1. So that's no good. Let's have a look at the other one. So 2 times by 5 is 10, so 10 and 16. We're not going to make 12 out of that. And timesing 16 by 5 would give us 80 and 2, so that's no good. So 4 and 8, hopefully it's this one. So 4 times 5 is 20, 20 and 8 we can make 12 out of. So we want our 4 to turn into 20, so 4 can go here, and 8 in our other bracket, there we go. Now we want to make negative 12, so we want positive 8, so plus 8, take away the 20, so take away the 4, and that would give us negative 12. Right, okay, moving on to the next bit then. So finding our solutions, we've got x equals 4, and we've got x equals negative 8 over 5. There you go, negative 8 over 5, and you can write that as a mixed number if you want, but there we go, we've got negative 8 over 5. Right, so we've got our two x values, we just need to sub them in. Again, we've got this formula up here, or this equation, we've got y equals 2x minus 3, so we just need to sub those in. So let's do the easy one first. When x is 4, y equals 2 lots of 4, take away 3. 2 times 4 is 8, take away 3 is 5, so y equals 5. There we go, and there's our first pair. On to the slightly harder one here, we've got when x equals negative 8 fifths, we just need to sub in negative 8 fifths. So y equals 2 lots of negative 8 fifths, take away 3. So let's work that out. 2 lots of negative 8 fifths, again times in the numerator, we get negative 16 fifths, take away 3. And again, let's write that as a mixed number and then we can take away 3. So 5 goes into 16 3 times, so it would be negative 3 and 1/5. And we're going to take away 3, and negative 3 and 1/5, take away 3 equals negative 6 and 1/5. There we go, not very nice there, negative 6 and 1/5. Right, so our solutions there, which we can write out again, we have when x equals 4, y equals 5, and our harder one there, we had when x equals negative 8 fifths, y equals negative 6 and 1/5. Again, you can write them as top-heavy fractions, or you can write them as mixed numbers. It doesn't actually matter either way there. Okay, or you could write them as decimals, but there we are. There's a non-calculator method looking at these slightly harder ones. Right, now we're going to have a look at one last type of question here where we are going to need a calculator. Okay, so get your calculator and let's have a look at one of these harder ones. Okay, so this says, solve the simultaneous equations and give your answer to 3 significant figures. And that is a massive hint there in the question that you're going to be using the quadratic formula, because it means that our answers are going to be some quite nasty decimals. Okay, so we're going to be giving it to 3 significant figures. It just gives you a massive hint that we're not going to be able to factorise this at the end. But let's take exactly the same approach and see what we get. So for this first equation here, I'm going to make it y equals to avoid having to divide by 2. So let's just rearrange that to start with. We'll take away 2x from both sides, and it will say y equals 3 minus 2x. Okay, and let's sub that in for y then. So subbing that into that top equation, we're going to get x squared plus this 3 minus 2x, that's squared, and that equals 20. Now if we expand all this out, we get x squared plus, and you can write out the double bracket here if you like, but 3 times 3 gives us 9. We get minus 2x times 3, which gives us minus 6x, and we've got 2 of those, so minus 12x. And then negative 2x times negative 2x will give us positive 4x squared. There we go, and that equals 20. I'm going to rearrange this, tidy it all up, so the x squared and the 4x squared will equal 5x squared. We've got the minus 12x, and then we've also got, let's have a look, let's write this in, minusing the 20 there, I'm going to do it in one step, so we've got 9, the positive 9, take away 20 gives us negative 11. And that equals 0. Now you can see from that our factors, our factor pairs for 11 are only 1 and 11, and if one of them gets times by 5, we've got 5 and 11, or 55 and 1, is it? Let's have a look, is it, yeah, 5 and 11 or 55 and 1. Neither of those pairs are going to make negative 12 in the middle, so we're not going to have the option to factorise here. So we're going to have to use the quadratic formula. So obviously, you're going to need to know the quadratic formula for this, so do obviously check out the video on that if you're not sure on it. But we've got a equals 5, the coefficient of x squared. We've got b equals negative 12, the coefficient of x, and c equals negative 11. Okay, so we're going to sub that into the quadratic formula. So obviously always just write the quadratic formula out before you start substituting it in. So let's write it out. We've got x equals minus b plus and minus the square root of b squared minus 4ac, and that's all over 2a. And if we sub these in, we've got quite a lot of steps here, but let's sub those in. So negative b, and that's negative 12, so negative of negative 12 would be positive 12. So we have 12 plus and minus the square root of, a little trick for the quadratic formula, when b is negative, a negative number squared is going to be positive anyway. So I mean, you can write it in like this, negative 12 in brackets squared, but I would probably just type in 12 squared. It just avoids making that negative error on the calculator. So obviously just be careful that you do put it in brackets, because if you put negative 12 squared in your calculator, you'll get negative 144 and not the positive 144 that we know it is, unless you put it in a bracket. So negative 12 squared, take away, and we've got 4 times a, which is 5, times c, which is negative 11. Just extend that, there we go. So that's what I'm going to type into my calculator, and it's all going to be divided by 2a, which is 2 times 5. Okay, again, I'm using the Casio ClassWidth, so I'm just going to type it in. Again, I've put the link for that in my description if you're not sure on these, because it's quite hard on some of the other calculators, but as long as you've got one of these dual level calculators, it's quite nice and easy to type in. Now what I'm going to do is I'm going to type it in twice, once with the plus sign, once with the minus sign. So the first one I'm going to type in, I'm going to do my plus, and I'm going to see what we get for that. Then I'm going to do the minus, and we'll see what we get for that one. Okay, right, so fraction button, I've got 12 plus, let's have a look, square root, in brackets, negative 12, close brackets squared, take away 4 times 5 times negative 11, and then onto the bottom of the fraction, 2 times 5, which is 10, so I'll just type 10 in, equals, and you normally get like a little surd answer or a fractional answer here, so I'm just going to press your S to D button, turn it into a decimal, and for that positive version there, we get 3.10787, and a few more decimals, but it only wants it to 3 significant figures, so don't forget that. So I'm just going to write it down to 3 significant figures. So for the plus version, I get 3, which is my first significant figure, 0.107, so that's 7 rounds the 0 up to a 1, and I get 3.11. Okay, so there we go, there's my first solution. It is always sometimes worth just writing the whole digits down, so if I just write them down, we get x equals 3.107. 878,403. There we go. So that's the full answer there, but I've just rounded it to 3 significant figures. So go back into the top of the fraction. I'm going to go all the way back without deleting anything. Delete the plus sign, turn it into a minus sign, and press equals again. So for the negative version there, I get negative 0. And here's my first significant figure now, 7, 0, and it's 7, 8, so the 7 rounds up to an 8, so negative 0.708. If I write down the full one over here, we get negative 0.70787 84028. 84028, if I can fit that in, there we go. Right, so obviously I've just rounded it to my 3 significant figures there. So let's have a look now. Obviously what we've got is 2x values that aren't particularly nice here. They're both horrible decimals, but we are using a calculator. So substituting these values back into our equation isn't going to be too bad. So I'm going to sub it back into this equation here. Y equals 3 take away 2x. So I'm just going to get rid of some of the working out here so we can see this. We've got our x values. I'm just going to remove all of this here. Okay. Right, so let's have a look. So when x equals 3.11, we've got y equals 3 take away 2 lots of 3.11. There we go. And what I am going to do actually is I'm going to sub in the original values when I do this, and that's why I've written them down in full, just to make sure I don't make any rounding errors here. But in my working out, I'm just going to write there 3.11, so my answer might be different here as if I had have subbed in 3.11, because I am going to sub in these original values just here, okay, which is why I've written them down. So on my calculator, 3 take away 2 times, and let's type that all in, 3.107 878,405, I think it was. Just make sure you write it down clearly so you can read it, and press equals, and I get y equals negative 3.215, so 3.22. There we go, rounding that again to three significant figures, although it was negative 3.215. Okay, and that 5 rounds it up. So there's our first solutions. We've got when x is 3.11, y equals negative 3.22. Okay, that's my first set of solutions there. And for my second one here, let's have a look what we get. So our second one there, we had x equals negative 0.708. And again, I'm going to sub in the original number there, but obviously just be careful with that, okay, because I just don't want to get any rounding errors. So if I sub that in, y equals 3, take away 2 lots of negative 0.708. And let's see what we get for y. I'm going to have to type this in again. So I'm going to go back into my calculator. I'm just going to delete that old one. 3 take away 2 times negative 0.7078 784 028 at the end, I think. Doesn't actually matter as we get this far into the decimals. That's not going to have much effect on my answer. But there we go, press equals, and we get y equals 4.415. The 5 rounds it up, so it's 4.42. But again, you can write down all the digits and then round it afterwards. And there is our second solution. Okay, so x equals 3.11 and y equals negative 3.22. And for the other one, x equals negative 0.708 and y equals 4.42. Okay, obviously after rounding that to three significant figures. So quite a lot going on there. Very similar process. You've got to be quite happy with the previous questions actually to extend it onto these with the quadratic formula. But let's have a look. I've got one for you to have a go at before we finish. Okay, so here's your question. Last question we're going to have a go at. So pause the video there, have a go, and we'll go over the answer in a sec. Right, okay, so let's have a look at this. So for this second equation, I'm going to make it y equals, so I'm going to add the y over to start with, and do it up here, so we get 2x equals 3 plus y, and then subtracting 3, we get 2x minus 3 equals y. Right, there we go, so we can sub that in now. So we've got y equals 2x minus 3. So let's sub that in, we get x squared plus 2x minus 3 squared equals 27. Now let's expand that out, tidy it all up. So we get x squared plus, and let's do this, I'm going to skip steps, so 4x squared minus 6x twice, so minus 12x plus 9 equals 27. Tidy this up and make it equal 0. So 5x squared minus 12x positive 9, take away 27. You have a calculator this time, so you can always type that in if you're not sure. Minus 18, there we go, saves you making a little error on little takeaways there. And that equals 0. Right, so using the quadratic formula here then, let's actually work this out. So x equals, and let's just actually label what a, b and c is. Actually, I won't write the quadratic formula out because I've already written it out once, so hopefully you've already got it written down. X equals 5, b equals negative 12, and c equals negative 18. Right, so if we write this all into the formula then, we get x equals, that's a bit of a weird x there, let's rewrite that. So x equals minus b, which again is negative there, so it's positive 12, plus and minus the square root of negative 12 squared minus 4 times 5 times negative 18. Right, there we go. And that's all over 2a, so it's all over 10 again, 2 times 5. And let's type these in. So I've got my plus, and that's not written very well at all. Right, let's have a look. So I've got my plus, and I've got my minus. I'm going to do them both separately. So when I put the plus version in, let's type it in. So fraction button, 12 plus the square root of, in brackets, negative 12, close brackets, squared. Take away 4 times 5 times negative 18. And then onto the bottom of the fraction, 10 on the bottom again, equals, turn it to a decimal, we get x equals 3.44. So 3.44. There we go, and you can write the whole decimal down if you want. I think this time I'm just going to use 3.44 and just go for it and see what we get. Right, so back into your calculator, press minus again. There we go, so change the plus for a minus, press equals, and you get for this value, for the negative one there, x equals minus 1.04. Minus 1.04, it's a 4 after the 4, so that rounds to minus 1.04. Now let's sub these in, again using this equation here, so y equals 2x minus 3, So y equals 2 lots of 3.44, take away 3. And if we type that in, so 2 times 3.44, take away 3, and we get 3.88. So y equals 3.88. I'll have to rewrite this again in a sec. And let's have a look. For our second value there, we get y equals 2 times negative 1.04. Again, take away 3. Type that in, so 2 times negative 1.04, take away 3, and that gives us negative 5.08. So y equals negative 5.08. Again, if you sub the full values in there, you might get ever so slightly different answers to these, but there's an error of a margin of error that's allowed with your rounding here, obviously, because we're subbing into quite a complex little equation here with those long decimals. So we get our set of answers. We've got x equals 3.44, and with that, y equals 3.88. And for the second one, we have x equals negative 1.04, and with that value, y equals negative 5.08. Right, there we go, and that is the end of quadratic simultaneous equations. Obviously quite complex there at the end, but obviously well done for sticking through it. You can always go back, have another go, figure out some of the questions, but if that was helpful, if it was useful, please like, please comment, please subscribe, and I'll see you for the next video.